So I was asked to address a topic of great interest this year, and that's soil fertility in a post-drought year, which I hope this is. And then as an extra kicker, we have very high fertilizer prices, so I will talk about that extensively through this presentation as well. So unless you took last year off, you know that last year was very dry until late July in many areas of North Dakota. There were a few areas that were dry even after that, but in most areas there was some rain starting in late July through August, September. But harvest went really well, and I think things, for the most part, at least in the lake region, went pretty well. That yields were in large part greater than expected, or certainly no worse than expected, and so that was great for many farmers and a huge relief. Moisture came late in the season, and that's opposite what happens in most years, and maybe that's why we're seeing what we're seeing in our soil test nitrate. Our soil microbial activity was extremely low in the spring, as you might expect. With no water, there's very little microbial activity at the surface. That continued into early summer and likely increased with the late summer and fall moisture that we received. In many fields, growers and their consultants report that their residual soil nitrate values are higher compared to normal values, and the question arises a lot about whether these high values are really real or not. There's a lot more confidence with high values in a zone tested field compared to a field composite sample. There are a lot of fields across North Dakota, especially with really competent consultants that are zone soil sampled, and when you have a series of zone samples and they're all testing higher than normal, then I think you have very high confidence that these figures are real. If you just have one number from an entire quarter, for example, and that number is fairly high, then I think it's right to question it. And so here's just a little example. Let's say that cores were pulled across the field, and of course the person that's taking the cores doesn't know that these values exist, but let's just say that they do. If a person had taken every core and analyzed it separately in a 2-foot depth, that the average value for all those cores, with ranges from 20 to 200, the average value is 48 pounds of nitrate N per acre. And part of the field, if you use that as your basis for fertilizer, then about 7/11ths of that field, more than half, would be over fertilized, and quite a bit of the field would be under fertilized by 20 pounds an acre. So that's quite a range. When you have a kicker like that, when you have large numbers that appear, then you really don't know exactly what the variability is across the field and whether that number really reflects the value of the field. If you come back with a composite test at 20 pounds, let's say, then you could be pretty assured that within 10 pounds one way or the other, that almost all the field is going to test within that range. But once you get above, say, 40 pounds an acre, then that means that there's quite a bit of variability across the field, and you should be doing something else than a composite test. So the way to sample field in North Dakota for almost all situations, and we'll talk about the exceptions because I don't have time, but in most situations, a zone by landscape or directed by aerial photography, could even be a drone image, it could be a satellite image, it could be multi-year yield maps, and some people have access to electrical conductivity sensors from their consultants, and all of those things can be used to make a zone. So again, just as an example, let's just break this field up into zones, and testing them, we find that the really high value came from maybe a saline area, that maybe didn't look saline because of the way the field was worked. Couldn't really tell. But anyway, when it's sampled, and it should be in a field composite because that's important too, it sampled at 200 pounds of N per acre. Of course, that area isn't going to need any nitrogen at all. The area up in the northeast, the value of those higher cores in that area were 45, and the area of the rest of the field was 28. So that's a pretty good reflection of what that field really is from those cores that we showed before. So again, when you see a 200, when your zone sample, you believe it. When you see the medium one, you know that it's going to be, plus or 10 pounds or something from that. And when you see the low one, you know that it's probably going to be even plus or minus 5 pounds from that. So it's a lot more confidence in the soil test from your zone sample. So if your composite sampled field comes back with a high value, have it zone sampled whenever you can to make sure it's really high. Or if or maybe it shows high because the sampler took a few samples from a salty area, and that skewed the results. You really don't know. So a zone sample, and a composite sample, it's hard to tell. So the most important thing that you can do after a drought is have the field zone sampled for soil nitrate. Your soil P, K, pH isn't going to vary much from year to year. If it does vary at all, it's probably because of the depth of the sampling, maybe because of the tillage made it really hard for the sampler to figure out what depth they're really going to. But the nitrate N is certainly going to vary widely for the year. So sample each field, not just a representative field. I know some people do this. I just think it's weird that a person has 20 fields and may sample 2 fields and then fertilize based on the results from those 2 fields. It's a total disregard for the personalities of each of the fields. One size doesn't fit all. Each field is unique. Each field has different properties. Most of the fields are going to have different values of fertilizer, and so have to sample them all. And it's a very small cost compared to the cost of fertilizer. Your fertilizer bill this year might be well over $100 an acre. And if you spent $5 an acre to try to get a really good soil test, my gosh, what a great return that is. There's no CD in the world, there's no investment in the world to do better than that. The soil nitrate N is very important in producing a profitable fertilizer N rate. I'm very pleased. I'm really gratified that this fall, up until now anyway, the soil samples coming into various labs is much higher than it has been in previous years, and part of that is just because people hear the word around the coffee shop that nitrate values are higher, and so sampling will give an idea about how much they could reduce the rate. And the other is we just had a beautiful fall in order to take soil samples in, so the ability to take them was a lot greater than it normally is. So once we have the soil nitrate value, we subtract that from whatever the fertilizer N requirement is. And the fertilizer N requirements are in North Dakota are designed to maximize farmer profits and not necessarily yields. We're all kind of tuned to get the biggest yield possible, but oftentimes that cost of the last couple bushels of wheat or the last 5 bushels of corn is way more expensive than to make than the check that we're going to get from the elevator for producing that extra amount. So the fertilizer response is not linear. It doesn't go up at the same rate with every increment of fertilizer. It's a curve, and I'll show you that in a little bit. So what we use to develop our fertilizer recommendations in the state, in North Dakota, for wheat, for corn, for sunflowers in particular, because those are the crops that we have the largest database, is what's called an industrial economic production function. So it's based on the law of lessening returns. So with every increment of fertilizer we apply, each additional increment gives us a little less yield. and sometimes less quality as well, which has to be factored in. So these are the curves for corn, for example, just one page out of one table in the circular, or just a couple clicks on the nitrogen calculator on the website, or in the phone app. So these are curves. The bottom one is $1 a pound nitrogen, which is kind of what we have right now, and then $4 corn, which is kind of less than what we have right now, but it gives you an idea of what the internal workings of the app are going to be. So this top one is with 20 cent a pound of N, and you know, we've had that in the past, actually not more than a few years ago. But the most profitable N rate to use when you had 20 cent N, $4 corn, was well over 200 pounds of N. This is based on medium textured soils in eastern North Dakota. But when we get down to a dollar a pound of N with $4 corn, then the N rate that is most profitable is not quite half, but it's certainly a third less. It's more like 140, 150 pounds of N or so. And that's before we take any credits off for that too. So this is, so there's a big difference. This is the most profitable here. You know, the most profit is what, about $525 an acre. Up here it was $680 an acre, but that's just because of the cheap N. But when we have the expensive N, we have to live with it. If we use the same rate of that, our profitability, instead of being $525 an acre, would be more like somewhere around $475 an acre, which is, you know, what, $60 less or so than that. You know, the reason we put on fertilizer is to make profit, and if we're not making any profit by putting on the fertilizer, why in the world are we doing it? So the rates are very much linked to profitability. So this is what the calculators look like. If you go to the website, this is what they look like. If you use the phone app, they're not going to look exactly like that, but they're going to have all the components. So first thing we ask for is where you're going to be in the state. And in eastern North Dakota, once we get up here to Devil's Lake or so, north of the Devil's Lake area, we have the Langdon area, and that's an area where the nitrogen rate is a lot less because there's a lot of broken up shale in it, because the distance from the surface of the soil to the bedrock shale is relatively shallow. It's not great, really deep, 40, 50 feet maybe all the time, and so the shale pieces are a lot more prevalent in that area than they are outside of that area where the distance from surface to bedrock is greater. So that makes a difference, because that shale has a large amount of mineralizable ammonia in it, and so the soil itself acts like a slow release fertilizer, so the fertilizer rate doesn't have to be as great as it is in the rest of North Dakota. So this may not be the only place within the state. I've heard of a couple other farmers have talked to me, and they said they have a lot of shale in their soils, and if you do, you could probably back off your nitrogen rates there too and use eastern North Dakota. But for the most part, you're going to be part of this eastern North Dakota district. So that makes a difference, because the sites that went into the recommendation are different in eastern North Dakota than they are in the Langdon area. Then we look in the wheat, we look at low productivity, medium productivity, high productivity. In this region, you're either going to be medium or high. You're really not going to be low. If you're low, it's probably because of salts, and the soil nitrate value be so high you wouldn't put any on anyway, so it doesn't really matter. So the medium productivity areas are areas that often yield 60 bushels or so, maybe up to 60, and high productivity is when you have any kind of moisture in the soil, you have yields above 60 bushel, then you go with that one. And that's in there purely for economics, doesn't make any difference on the shape of the yield curve at all. Then you put in the nearest wheat price per bushel. Right now it might be around 7 or so, and then indicate previously planted crop in the field. If you had soybeans, for example, or field peas, then you would check that and you get a credit for that. And you put in the nearest end cost, which right now is about $1 a pound, and the calculators go up to $1, so they don't go any more than $1. We'll have to revise them, I guess, because I never envisioned that we'd be paying $1.20 for nitrogen, but we might. And once you do that, then you get a kind of a recommendation. You put in your soil test and click OK, and then you put in your tillage. If you're long-term no-till, 6 years or more, we know that you get a credit. You don't need as much nitrogen in long-term no-till as you do with conventional till or intermittent no-till. So that enters into it, and then your final recommendation is down here in the bottom. And then there's plus or minus 30 pounds because it gives you credit for common sense, because you know what varieties you're doing. Are they high protein varieties? Do they struggle getting protein? All of those things enter into your recommendation. So that's the wheat. The sunflowers, they take into account the oil loss with added N. They take into account the risk of lodging with higher N rates, and then of course they also take into account the increase in seed yield with increasing N, at least up to a point. So again, eastern North Dakota, western Langdon area. I know there's a lot of confections grown up here, and so you take that into account. Tillage considerations, previous crop. Most of the time you're going to be grain or corn or so after this. This likely probably doesn't enter into it too much. The sunflower price in cents per pound and nitrogen cost, again, percent organic matter in the soil, up until 5.9%, that's really not considered. If you get over 6%, which over here in the very northeast part of North Dakota, you get some areas that are above 6, then you back off the N rate because you get excessive mineralization. And then the soil nitrate test, of course, your nitrogen recommendation after credits. So it's basically pretty similar to what the wheat is. And then corn, you're in eastern North Dakota, you're either no-till or you're not. There's a little bit of irrigated corn up here, but not very much. All of that brings you into a different data set. And then medium textured soils, you're going to be in those. I don't know, well, there are some high clay soils up around Botno, so it's possible you could be in a high clay soil. So you put all these in the soil test, previous crops. If you had soybeans, for example, that would lower your N rate. So all of those, and it's all nitrogen cost and corn price dependent. So, you know, in the old days, we had certain formula times yield gold equals N cost, but this is a lot of numbers, not all of them in our wheat data set that we made our original recommendations from. This is the actual response here. This is if we would have had a 2.5 times yield goal. It's really not related to that cloud at all, but this is a lot, and it certainly is once you put in relative yield, which is what we use these days. So we started looking at what in the world we were doing and why this is really working. It's easier to kind of show you what's going on with the sunflower. Each of these sunflower tests we did in 2014, 2015 were very strong related to nitrogen rate, but when we put them all together, it looks like this big cloud. The relationship is really horrible. 0.0267 is really horrible. 0 means there's no relationship at all, so it's really close to that, so that's weird. So this is kind of what we look like in a less cluttered scale. We're putting all the sites together with the actual yields, but really what we're looking at and what we looked at with that previous slide with all the data points and the really low R squared was just almost parallel quadratic curves packed on one on top of the other. The lowest one being the lowest yielding environment, the highest one being the highest yielding environment, but the shape of the curve is remarkably similar between sites. So what we did is standardize the data from all of these, the wheat, the corn, the sunflowers. For example, we had a sunflower site that had a high yield of about 4,000 pounds. So every yield in that site we divided by 4,000, so we had values between 0 and 1. And then we want to keep it on the same scale. So if we had a lower yielding sunflower site with high yield of 1,800 pounds, we divide all the yields by 1,800, and we reach values between 0 and 1, and then one in the middle that maybe had a high yield of 2,500, we divide all the yields within that site by 2,500 to again get values between 0 and 1. So all of the sites are on the same scale. So when we do that, what we'd expect to see is that the dots, the relative values, will collapse around that quadratic curve, and the R squared will be a lot higher. So did that happen? Yes, it did. These are, in the upper left will always be the raw values, and the lower right will always be the standardized graph of the standardized values. So the raw yields, Western North Dakota conventional till, the R squared was 0.16, but when we had the same data but did that standardization and put them on the same graph, then our R squared tripled, more than tripled, up to R squared of 0.53. No-till wheat sites out west, R squared was 0.19 in raw, and when it's standardized, it more than tripled up to 0.67. In corn yields, here on the left is the Eastern North Dakota high clay conventional till, R squared 0.22. And when we put it standardized values, the R squared more than doubled up to 0.47. And here are the no-till values out west, R squared 0.2. And when we standardize those yields, the R squared went up to 0.68, more than tripled. And the sunflower yields, conventional till 0.14. Raw yields, and when we put the standardized yields up there, the R squared tripled up to 0.41. And just lately, the last couple of years, we've been working with 2-row barley. If we use just the real values of it, the R squared is so low you didn't think there was any relationship there at all. But when you standardized all those yields, the R squared went up, phenomenally to 0.55. So people have a hard time wrapping their head around this. Even consultants that have master's degrees sometimes have told me that they just have a hard time wrapping their head around it. So think about it in terms of fertilizer efficiency. If we have a low yielding environment, it's usually because it's really dry or because it's wet. And you in the lake region have certainly experienced both of those in the last 5, 10, 20 years. So when that happens, the microbial activity is a lot lower, either because the pores are plugged with water or because it's so dry they haven't had water to live. So their mineralization is really low. The root systems are very challenged. They don't go down as deep as they usually do in either environment. In a dry environment, nitrate moves to the roots by a process called mass flow, and the water is mass and there is no flow, and so it's a lot harder for any crop to take up nutrients when it's really dry than in what we consider a normal year. Also, when it's really wet, the nitrogen is subject to leaching loss. It's subjected to denitrification loss as a gas. So it takes a lot more nutrient, nitrogen, maybe any nutrient, to make a bushel or a pound or a ton of a crop than it would in a normal year. In a high yielding environment, the moisture is ideal. It's not too wet, not too dry. The losses from leaching and losses from denitrification are very low. There's enough water in the soil to move the nitrate to the root, and so it doesn't have to work as hard, and the roots can grow to their full genetic potential because there's moisture, but not too much moisture, and so they continue to grow and explore way more of the soil volume than they do in either a wet or a dry year. There's a lot greater nitrogen mineralization than there is in a normal year. So the net result of all of those in a high yielding environment is it takes a lot less added nitrogen to make a bushel, pound, or ton than it would in a normal year. So the net result of all of those and everything in the middle is that the rate of fertilizer to reduce economic maximum yield in a low yielding environment is very similar to that in a high yielding environment, and so it's not related to yield goal at all. Yield goal totally dismisses the power of the soil to supply nutrients. Our wheat nitrogen calculator came from farmer field studies. Only 1 or 2 came from experiment stations themselves. Over 50 were performed by myself between 2005 and 2010, and then over 50 site years from archive data from the late 70s up to 2005, and all had a check and an end treatment, same kind of design that enabled statistical analysis, and all were taken to yield, and all had protein gathered. So there were certain points about the archive data that I had to have before I used it in the study. So we had the relationship of the nitrogen rate with the yield, and the relationship of the nitrogen rate, and it's not just the rate, it's the total known available N with the grain protein. And we considered the value of the bushel and dockage from low protein or premium from a protein range of 14% to 15%. With the corn calculator, we developed it with field data, all with a check, all with multiple N rates, all in the same design. About 123 sites. Most of the data was generated by my shop, including Dr. Sharma, who's now a professor down at University of Florida, and Hongdang Gu, who's currently my technician and programmer. I did all the apps. We also had 23 sites from Northwest Minnesota, courtesy of John Lamb, now retired, and Russ Severson, likewise retired. And then 6 sites from the northern tier of counties in South Dakota from Ron Gelderman, also retired, and 9 sites from southern Manitoba, courtesy of John Hurd, who's still there. Our sunflower work was conducted 2015-16 by my shop with Dr. Sharma and Mr. Schultz, and he is a BASF tech rep down in Nebraska right now. There were 28 sites in North Dakota, mostly in the western half, since most sunflower is grown in that region. We had conventional till sites, no-till sites. We had confection sites, largely up in this area, and then we had oilseed sites that were scattered between western North Dakota and eastern North Dakota. All had a zero check, N rate, same design. We measured yield, the lodging score, and oil concentration of the oilseed cultivars. So just to give you an idea what N rate does to lodging, this is out in Bottineau, North Dakota, not too far away from us, and as the N rate increased, as the total available N increased, the lodging score greatly increased, so we have to modify that a little bit with our rates. And then sunflower oil, and this is true with canola too, but the processors really haven't made this a priority with canola. Maybe someday they will, but they certainly do with sunflowers. But when N rate increases, the oil content increases. So again, this modifies the N rate, because again, we're looking for profitability. One thing we found that really nobody else has really put into print yet, Sam Markell helped me with this, as well as Roger Ashley, who's retired plant pathologist out at Dickinson. He did it during his retirement time. Is sunflower rust increased with N rate, and I think white mold does too, but we were unable to measure it. I didn't think about it in time to do the measurement, but I'm pretty sure that happens too. We have phone apps for Android phones and iPhones also. So go to the App Store, look for North Dakota Crop Nitrogen Calculator, free to download. So do that, and also on my webpage, the calculators exist there as well. How about the other nutrients? The North Dakota potassium calculator also takes into account the cost of potassium fertilizer, as well as the clay type that may be in your soils. And so that's already in our recommendation. The phosphate fertilizer profitability also depends on the phosphate fertilizer cost, but we don't have a phosphate calculator. But I will show you this. It's in a very obscure publication that Ardell Harverson, who's used to be head of the ARS station in Bandon, he put in just a proceedings, but he figured out that And it's logical that with a fixed crop price, that as you increase the phosphate cost, then the profitability of putting on phosphate has to go down. It just has to. And so that's what he looked at. He looked at the critical value of soil test phosphate with increasing phosphate prices. So 30-cent phosphate price, critical value for wheat somewhere around maybe 14, 15 ppm to break even. That's your break even critical value. When it goes up to 50 cents, it goes down a little bit, maybe to 11 or 12. But when it gets up to $1 a pound of P2O5, which is pretty close to what it is right now, the critical value for either getting profit or loss is less than 10. It's probably more like 7 or 8, and this is for wheat. So with phosphate prices the way they are right now, you certainly have to maintain your seed placed fertilizer, because that's where you get your huge kick with the wheat, with canola, with corn, potatoes, not sunflowers, sugar beets, any of your small grains. That's you have to put a little bit in regardless of soil test. But the value of putting, say, a broadcast application on when you have P tests that are greater than maybe 7 or 8 part per million, even in wheat, it's not a lot of profit there. You're not going to get a return that year that you're doing it. So I would save my money and use my starter and go from there. So here are the takeaway points to consider. And in my live presentation, of course, there'll be plenty of time for questions. For those of you that are online, you can get a hold of me another way. But these are the takeaway points. The yield increase with added fertilizer is not a straight line. Don't think about yield times some fictitious value, because it doesn't work. It's not. It doesn't reflect what's going on in today's environment. So the nitrogen calculators and the corn potassium calculator take into account the yield and quality of added fertilizer and the cost of the fertilizer to get there. And it's most important, and I can't emphasize this enough, you need to maximize your profitability, not maximize your yield. If you want to do both, go ahead and use a calculator, and then when you go to the coffee shop, lie. So, and I think you get that. With a fixed crop price, increasing fertilizer prices of any kind dictate that rates have to be less than those maximizing profit with lower fertilizer prices. And then finally, I want to leave you with this: that there's hundreds of products out there that tell you that if you use them, that you could decrease your fertilizer use, and they're very poorly researched. There's some of them that have some research. If there's positive results, it tends to be very inconsistent. And in a year like this, when you need consistency, I'm just not sure. So I would really strongly recommend that you stay away from any of those things that promise you can reduce your rate of P, you can reduce your rate of K, you can reduce your rate of nitrogen. Do they take the place of fertilizer? Certainly. It's not up to you to do their research. They need to do their research first and then go to you with some very consistent results. So please stay away from those. They're not going to increase your profitability at all. And here's my contact information. If you wanted to call me, text me, email me, there it is right now. And thank you for your attention. Have a good rest of your day.